Hello, algebra students. We're going to take a look at functions and equations, and this is section 8.7. We're going to start with a little warm-up. We want to remind ourselves about slope-intercept form. When we're given the slope and the y-intercept, we can write our linear equation in slope-intercept form. We just put in the slope for m, and we put in the y value for the y-intercept at b. When we are given the x-intercept, we're kind of thinking about, okay, we put our slope in for m, and then we can plug in our x-intercept, which would be 5, 0 in this case. And to do that, we plug in our 5 for x and 0 for y. And then we solve for b. Here we would add 9 to both sides, and that gives us a b value of 9. So we can say y is equal to negative 9/5 x plus 9. When we're given two ordered pairs, we have to calculate the slope first. Remember that your slope is y minus y over x minus x. Find the slope of that line. And so we would get 8 over negative 6, and of course that reduces to negative 4/3. Then we follow the same procedure as the last one, where we're plugging in our slope, and we choose one of the ordered pairs. I'm going to use 2, 2. And solve for b, and that b value is 14/3, and so we get y is equal to negative 4/3 x plus 14/3. And again, yeah, that should be familiar to you. If you're not sure about those things, make sure you're asking your algebra teacher about it. We're going to move on to functions. So a function is a correspondence between two sets. And that is the domain and the range. The domain represents the independent variable. That should sound familiar from science. And that is the same as the x values. That's our input. And our range is our dependent variables. Or our y values. Or what is typically our output. It is important to realize that it assigns each member of the domain actually one member of the range. So for every x input, there is a, not necessarily unique, so let's cross that out. There is a single output and not the other way around. So if we're looking at the set here of birthdays of these famous people, is it a function? What we're asking ourselves to determine if something is a function is, does each x value have only one y? So the x's can't repeat with a different y value. In order to be a function. And so if we think about this birthday rule, the idea is that you have George Washington's birthday is February 22nd. Marie Curie's birthday is November 7th. Charles Darwin is February 12th. Abraham Lincoln's birthday is also February 12th. The x's can repeat, but each x has a y. Like, so you can't have two birthdays. So this is a function. And that's a good idea to keep in mind when you're trying to think about whether or not something is a function. You know, does the x have more than one y possibility? A person cannot have more than one birthday. The birthday example is a good example of a function. If it doesn't fit with that kind of birthday setup, then it is not a function. So looking at the your turn, do the following ordered pairs create a function? Decide and answer on Edpuzzle. Hopefully you answered no. You can see as we list them with inputs and outputs. 2 has an output of 4. 3 has an output of 5. 7 has an output of 10. But then 3 has a different output of 6. So in the birthday example, the 3 has 2 birthdays, and that's impossible. So this is not a function. Graphically speaking, functions pass the vertical line test. I'm going to show you a little video clip that explains the vertical line test well.
What is the vertical line test? The vertical line test is a test to see if the graph of an equation is a function. To perform the vertical line test, we want to start at the very far left-hand side of the coordinate plane. Then, we want to draw an imaginary vertical line on that left-hand side. We then want to take that imaginary vertical line and move it very slowly from the left to the very far right-hand side of the coordinate plane. If the vertical line passes through no more than one point of the graph of the equation, then the graph of the equation is a function. If the vertical line passes through 2 points of that graph, then that equation is not a function. Even if that only occurs once, it'll still fail the vertical line test. Now let's look at a couple graphs of equations and perform the vertical line test on them to see if they're functions. So let's take this equation right here. To perform the vertical line test, we want to start at the very left-hand side of the coordinate plane and draw an imaginary vertical line. Then we want to slowly move that vertical line all the way to the right-hand side, and seeing how many times it passes through our equation. Well, if we start on the left, our vertical line passes through our equation 1 time. Here, it passes through the equation once. Here, it passes through once. And if we keep moving right, we see that it passes through once every single time. We make it all the way to the right-hand side of our coordinate plane, and the vertical line passes through no more than 1 point of the graph of the equation. So this means this equation passes the vertical line test, and this equation is a function. Now let's look at another example. Let's draw our coordinate plane, and then make our equation. We'll have a point here, 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 and here. Our equation will look like this. Now let's perform the vertical line test on it. Remember, we start out with an imaginary vertical line on the very far left-hand side. Now notice, on the far left-hand side, our vertical line doesn't pass through any points on our graph. Well, that's okay, because remember, the only way to pass the vertical line test is to pass through no more than 1 point on our graph. it can pass through 0. So, we pass through 0 times, and moving right, we continue to pass through 0 times until we hit the y-axis. Then we pass through once. Now we continue to move to the right, and we pass through once. But what about right here? If we draw a vertical line, we notice that our vertical line passes through not 1, but 3 points on this equation. We have a pass here, here, and here. There's 3 points where our vertical line passes through our graph. That means that this equation fails the vertical line test, and it is not a function. So, remember, the vertical line test helps you see if the graph of an equation is a function.
There are 2 types of notations for functions: arrow notation and functional notation. It's just another way to write the function equation line. Instead of using y equals, we use like f of x or f of n. In this case, we're going to look at arrow notation, and you might see p colon n and an arrow, fn minus 50. Now this part looks, right here, looks a little bit like the mx plus b part of the equation, and that is what it is. The p is just a letter that symbolizes a certain function. It can be really any letter that stands for any function. The letter that follows is your input value. We've typically been using x, but you can use other variables. We read this as p of n, and that means 5 times n minus 50. Now, another way to do this same kind of functional notation, which looks a little more traditional than like what we've been using, is we would, if we see p of n, again, same thing as the last one, that we can write it as p of n, in parentheses, p of n is equal to 5n minus 50. And the idea here is that this really is the same thing as the y value. And in this case, the n is the same thing as the x, or the input. So it's just another way to write the same kind of linear equation that we've been working with. So example 2, we're going to state the range of the function given the domain. Remember that the range is just a word for your outputs or your y values, and the domain is another word for the x's or your typical inputs. So we have a big statement here. This is read, m of x is equal to 3x squared minus 7. And we're telling you that the domain, or the possible input or x values, are -2, 0, and 2. So those are the only input values, or the only domain values we're considering. X is your domain. We have our domain possibilities listed for you. Then we plug in the domains to the function m of x to find our range possibilities. So I'm going to give myself a little spot for work and a spot to list the y values, or the range. So for the first domain value input, I have -2. So I'm going to use m of x, which is 3x squared minus 7, to plug in that domain value. So I plug in -2 for x. I'll do that work. I get 3 times 4 minus 7, and that's going to give me 12 minus 7, or 5 for that range value. For the next domain value, I have 0, so I'm going to plug that in. And I get -7. For the next domain possibility, I have 2. And again, I get 5. So the range possibilities here, so my range possibilities are -7 and 5. Remember, this is still a function. We can have repeated y values as long as each x has its own y value. We can't repeat the x values if the x values have a different y. In example 3, we're given the function g of x. It's stating that g of x is 3 times x minus 6, and we're asked to find g of -7. So that's telling you to plug in -7 for your x value and find the y. So we're looking at g of -7 being equal to 3 times -7 minus 6. 3 times -7 is -21, minus 6 is -27. So g of -7 is equal to -27. Now this is still an xy coordinate. Your x is -7 and your y is -27. Input, output. Your turn for the next one. You're being asked to find h of 5, given that h of t is t squared. So plug in your value for t and find t squared. Enter your answer on Edpuzzle. I hope you got 25. If you didn't, make sure you bring your questions to your algebra teacher. This one is a challenge, your turn. This time we're saying that given f of x, that f of x is 3x minus 4. You're solving for x if f of x, or y, is equal to 0. Try that and enter your answer on Edpuzzle. If you met the challenge, you got x is equal to 4/3 when f of x or y is equal to 0. It's really just another way to plug in the y value and solve for x. So we've looked at function notation as f of x. It's just another way to look at the y value, that it means the same thing as y equals. It's the function applied to x to give you the output, y. So let's do a little more practice with working with function notation. So let f of x, which remember is really just another way to write y, f of x is equal to 2x minus 5. So we want to find f of x, we want to find y, when x is -3. So we're going to use our function. So f of x is equal to 2x minus 5. We plug in our input or our x value. So f of -3 is equal to 2 times -3 minus 5. So that means that f of -3 is equal to -6 minus 5, or f of -3 is equal to -11. So finding f of x is just like finding y. Again, that gives us an ordered pair. Our input, x, was -3, and our f of x, output, or y, was -11. Now we can be given this function notation and we are given f of x. Again, f of x is just like looking at the output, or y. So we use the function f of x is equal to 2x minus 5. But when it tells us that f of x is equal to 13, then we plug in the 13 for f of x. So it's just like plugging it in for y. And then we would solve for x. And x is equal to 9. Again, we're looking for an ordered pair. So that means when y is 13, x is 9. You've done this before with the y equals mx plus b form. It's just a matter of looking at it with that f of x or function notation. So you have to be careful whether you're being given x or f of x. When you're given x, plug it in for x. When you're given f of x, plug it in for all f of x or y. When we're asked to graph a function, we typically rewrite the function in y equals mx plus b form. Again, notice, not a big change, just using y instead of f of x. We look for the y-intercept. The y-intercept here is 0, negative 3. And we plot the y-intercept. So going over to the graph, I'm going to plot 0, negative 3. Then we follow the slope. The slope is 5, 6. That's going to indicate that I go up 5 and over 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And I plot my point. And then I just connect the 2 points, creating a line that represents all the solutions to that graph, or that equation. Again, this is a function, just to review, because it passes the vertical line test. As I pass a vertical line across the coordinate plane, it only ever hits one point at a time. Let's take a look at writing a function. If we write a linear function g, given that g of 0 is equal to 10. Now remember, that 0 is your input, or your x value, but that g of 0 is representing y. So it's telling you that when x is 0, y is 10. And when x is 4, y is negative 2. So in effect, that is giving you two ordered pairs, just like you've been given before in y equals mx plus b exploration. So when x is 0, y is 10. And when x is 4, y is negative 2. So now you have 2 points, and you know how to find the slope when you have 2 points. You do y minus y over x minus x. So I'm going to take negative 2 minus 10 over 4 minus 0. And that's going to give me negative 12 over 4, which reduces to a slope of negative 3. Now we just need to find the y-intercept, or the b value. Now we could plug in our slope and an ordered pair, but I'm hoping by this point you notice that one of the ordered pairs we have is the y-intercept, because the y-intercept is when x is 0. So our y-intercept point here is 0, 10. That means our b value is 10. And so our function g of x, when we write our typical linear equation, is y is equal to negative 3x plus 10. Now to write that in function form, we just look at the letter representing the function, which is g, and we substitute g of x for the y. All right, your turn to practice. So let g of x, remember that's another way of saying y, be equal to the opposite of x plus 7. Find g of x when x is 4? Enter your answer on Edpuzzle. I hope you got 3. When you input 4 for x, your output, g of x, is equal to 3. Now try the other one. Find x when g of x, or y, is 9. And enter your answer on Edpuzzle. I hope you got that x was equal to 2. If you didn't get these correct, make sure you're bringing your questions to your algebra teacher. For the next one, we're just practicing graphing, and we have it in function form. So it's g of x is equal to negative 2/3 x plus 2. Now you don't have to rewrite it, but I like to rewrite mine in y equals mx plus b form before I graph them. It's really not a big change. I just like it in that form. And so I'm going to graph my y-intercept. My y-intercept is at 0, 2. So I'm going to plot that point. Then I follow the slope to get the next point. That slope tells me to go down 2 and over 3. Down 2, over, always over to the right, 3. Then I put another point. I'm then connecting those points. That represents all the possible solutions to that equation or function. For this next one we're graphing, h of x is equal to 3/2 x minus 1. My y-intercept is negative 1. So I'm going to graph that point at 0, negative 1. Then I'm following the slope. This slope tells me to go up 3 and over 2. 1, 2, 3, 1, 2. Then I plot my other point. And again, I just connect my lines to, let's try that again. I'm going to connect my lines to represent all the solutions to that equation. Make sure you're bringing your questions to your algebra teacher.